Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine you are running a shopping application. Your servers are running. Your application is showing green. CPU looks normal. Memory looks normal. But customers are complaining that checkout is taking 10 seconds. Some requests are failing. And some users are getting errors. So here's the important question. How do we know what is actually happening inside the application? That's where Azure Application Insights becomes extremely useful. Our previous videos taught us about Azure Monitor and Log Analytics. They help us understand our environment and analyze telemetry. But application developers and architects often need more specific information. Which API is slow? Which request failed? Which exception occurred? Which database call is taking too long? Which external API is causing the delay? This is where application-level observability becomes extremely important. Azure Application Insights is an application performance monitoring and observability capability within Azure Monitor. It helps us understand how our application is behaving. We can investigate requests, dependencies, exceptions, performance, and other application telemetry. In simple terms, Log Analytics helps us investigate logs. Application Insights gives us a deeper view into application behavior. Here's a simple analogy. Imagine going to a doctor. The doctor doesn't just ask, "Is the patient alive?" They look at heart rate, temperature, blood tests, and other signals. Application Insights works in a similar way for applications. Instead of simply asking, "Is my application running?" we investigate. How is the application behaving? That difference is extremely important in production systems. Application Insights can provide visibility into several important areas. We can investigate incoming requests. We can identify exceptions. We can see dependencies, such as databases and external services. We can analyze response times and performance. And depending on how telemetry is configured, we can also understand application usage. Together, these signals help us understand what is happening inside the application. One of the most useful concepts for architects is understanding application dependencies. A modern application rarely works alone. The application may call APIs. APIs may call databases. Services may call Redis. And payment services may call external providers. Application Insights can help us visualize these relationships. This gives architects something extremely valuable: a view of how the application components depend on each other. Let's take a real production problem. Customers say the order API is extremely slow. We could immediately blame the API. But Application Insights can help us investigate the request and its dependencies. We discover that the API itself is responding quickly. The problem is actually a database query taking 8 seconds. This is an important lesson. The component showing the symptom isn't always the component causing the problem. Now imagine a microservices architecture. One customer request may travel through several services. Order service calls payment service. Payment service calls an external payment provider. Another service may update the database. When something fails, how do we know which component caused the problem? This is where distributed tracing becomes incredibly valuable. We can follow a request across multiple components and investigate the complete journey. Now let's look at exceptions. Suppose our application receives 10,000 requests. Most succeed, but 150 fail. Application telemetry can help us investigate those failures. We can identify the exception type, investigate affected requests, and trace the problem back toward the source. Instead of saying, "Something failed," we can start answering, "What failed? Where did it fail and under what conditions did it fail?" Now let's see this in the Azure portal. We'll open our Application Insights resource. From here, we can explore the application overview. We can investigate failures. We can look at performance. We can explore dependencies. And we can use the application map to understand how different components interact. This is where application observability moves from theory into a real operational tool. Setting up application monitoring in Azure is straightforward. When creating a new Application Insights resource, you start by defining your subscription and resource group. Give your instance a unique name, choose your target region, and link it directly to a log analytics workspace to consolidate your data. Once your configurations look good, click Review and Create to provision your new monitoring resource. With the resource deployed, the Overview dashboard gives you a snapshot of your essential metadata. The most critical pieces here are your instrumentation key and your full connection string. You will need to copy this connection string to securely bridge your application's telemetry data over to this specific Azure workspace. Now let's wire it up in code. In your .NET Core project, open your appsettings.gesso file and add an Application Insights section containing your copied connection string. Next, jump over to your program.cas file. With just a single line of code, calling builder. Services.add Application Insights telemetry, your application is fully instrumented and ready to stream live performance data. Once your app is running, the Application Insights dashboard brings your telemetry to life. Right out of the box, you get real-time visual charts tracking failed requests, server response times, total request counts, and overall availability. It even features integrated code optimizations providing automated recommendations to keep your app running lean. When things go wrong, the failures blade helps you isolate the root cause quickly. It automatically aggregates your top response codes, like server 500 errors, and ranks your most frequent exception types, such as null reference exceptions. From here, you can see exactly which operations are failing the most and drill straight into samples or snapshots for a line-by-line look at the error. For deeper investigation, click into logs to leverage the power of the Custo Query Language, or KQL. You can write custom queries to pass through your exception tables, summarize counts by operation names, and render the output into clear visual charts like this donut graph. This gives you ultimate control to spot patterns, isolate anomalies, and optimize your application's health. Now let's connect today's topic with our previous video. Application Insights and Log Analytics are not competing products. They work together within the broader Azure monitoring ecosystem. Application Insights focuses heavily on application telemetry and application performance. Log Analytics provides a powerful environment for querying and analyzing log data. Together, they give engineers and architects a much stronger observability capability. Let's apply this to our shopping application. A customer submits an order. The request reaches the order service. The order service calls the payment service. Payment calls an external payment gateway. Other services may access Redis and SQL. Application Insights helps us observe this application behavior. If checkout suddenly becomes slow, we can investigate the request and its dependencies rather than blindly checking every server. Here's a simple framework I want you to remember. When something goes wrong, ask 3 questions. What happened? Where did it happen? Why did it happen? Metrics can tell us that something changed. Logs can give us detailed evidence. Traces can show us where a request traveled. Dependencies can help reveal why a service is slow or failing. That's how observability turns telemetry into an investigation. From an architecture perspective, here's the pattern to remember. Our application generates telemetry. We capture requests, exceptions, dependencies, and performance information. Application Insights helps us understand the application behavior. Azure Monitor provides the broader monitoring ecosystem. Log Analytics allows us to query and analyze telemetry. And finally, dashboards and alerts help operations teams respond to real production problems. This is the foundation of application observability in Azure. Let's finish with an architect challenge. Your checkout API normally responds in 1 second. Suddenly, it takes 12 seconds. CPU is normal. Memory is normal. The servers are healthy. So where would you look? Don't just look at infrastructure metrics. Investigate the application. Look at requests. Look at dependencies. Look at traces. Find the component responsible for the delay. That's the power of application observability. And remember, a healthy server doesn't necessarily mean a healthy application. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.